Earlier in this lecture, we applied the first law of thermodynamics to isochoric processes, where the work is equal to zero. We concluded that the change in energy is equal to the heat exchanged between system and surroundings during the process. So we wrote Q at constant volume equal to delta U, the change in energy. Many processes, such as chemical reactions and phase changes, occur at constant pressure. So we could ask whether the heat is equal to delta U for such processes as well. To answer this question, let us examine two different chemical reactions. The first chemical reaction we will consider is the thermal decomposition of solid calcium carbonate, CaCO3, into solid calcium oxide, CaO, and gaseous carbon dioxide. First, thermal decomposition, as the name indicates, is an endothermic process. In other words, you need to supply heat to calcium carbonate, put calcium carbonate in an oven to trigger the decomposition. So the heat Q is positive. Second, there is a net increase in the number of moles of gas as a result of this reaction. Specifically, each mole of calcium carbonate generates 1 mole of carbon dioxide. The reaction occurs at constant temperature and constant pressure, so the volume of the system can change freely as the reaction proceeds. Here, an increase in the number of moles of gas leads to an increase in the volume of the system. Recall that 1 mole of gas occupies on the average 1,000 times the volume of 1 mole of solid or liquid. So, in our volume calculations for chemical reactions, we only need to pay attention to the gaseous substance. An expansion of the system implies that the system is doing work against external pressure. Hence, the work is negative. So, in summary, for the thermal decomposition of calcium carbonate, the heat Q is positive and the work W is negative. Since delta U is equal to Q plus W and W is negative, then we conclude that for this reaction, Q is larger than delta U. One could ask oneself whether the heat is always larger than the change in energy for isobaric processes. So let us look at another chemical reaction to determine whether the result obtained for the decomposition of calcium carbonate is general or not. Let us examine the combustion reaction for tristearine, or glyceryl tristearate, a triglyceride obtained from animal fats. We write the combustion reaction in a usual fashion, combining the fuel with molecular oxygen O2 gas to form CO2 gas and water liquid. After we balance the chemical reaction, we note there are more moles of gas on the reactant side, 163 to be exact, than on the product side, 114. So the reaction can be viewed as an isothermal and isobaric compression. As for all compressions, the work during the process is positive. Negative change in volume, and W is minus P external times delta V. We then recall that all combustion reactions are exothermic, so the heat of reaction is negative. So for this chemical reaction, Q is negative and W is positive. Since delta U is equal to Q plus W and W is positive, then we conclude that for this reaction, Q is smaller than delta U.